We're going to find f prime and f double prime of this f of x. And we saw in the warm-up that this has a series representation that's equal to 1 plus x squared plus dot 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 plus x to the n plus dot 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 for absolute value of x less than 1. Okay, so we saw that that was true. It's a geometric series for this value. Okay, and so to compute then the f prime and f double prime, we know that as long as the series is convergent, right? We have the theorem that says as long as it's convergent, the series can be differentiated or integrated uh, on the interval of its convergence. Okay, so in particular, theorem 21, which is up above. Uh, so as long as it's on the interval where it converges, then those derivatives exist. So let's go ahead and compute f prime and then f double prime and see if we can determine if it produces a new series, some sort of new series with that result. Okay. All right. So f prime of x is going to equal, well, if we look here, we're looking at the derivative of this, right? Um, and we know the derivative of this is 1 over 1 minus x. Now the exponent of this is a negative 1. And so that's going to come up and leave us a negative 1. And then that's going to give us a square on the 2. But then we also, by the chain rule, have the derivative of negative x, which is also 1. Okay, so this is going to reduce then to 1 over 1 minus x squared. So that's the derivative of f of x. Now let's consider the derivative of the series. And we know the derivative of a constant is 0. So we're going to get left with this x here. So this becomes 1. This becomes plus 2x plus 3x plus dot 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 plus bringing that exponent down, you get n times x to the n minus 1 plus dot dot dot. And that continues on. And so we know that the closed form of this series is equal to x to the n equaling 1 equaling 0, sorry, to infinity. Okay. And so the derivative then is like counting up one step, right? And so we're going to be left with that this is like the derivative of bringing this down n times x to the n minus 1. And so we've kind of like stepped forward in our count. And so our n now is going to be at 1. N equals 1. And so this is now the series equivalent for this f prime. Okay, and now let's continue to take the second derivative. And you'll notice here that 1 over x minus 1 minus x quantity squared then has this series representation. Okay, all right, so let's look at one more derivative. F double prime of x is equal to, and the derivative of this is going to give us a 2 from the exponent. It's going to be a negative 2. Okay, and then we'll bring that back down. So that's 1 minus x cubed. And then the derivative of course, the negative x here is going to give us a negative 1 upstairs. So then this just leaves us with the derivative of 2 over 1 minus x, the whole thing cubed. Okay, so let's see, how does this right-hand side look like? All right, so the derivative of this now is 0. And so we have left the first term in our series is going to be 2 plus 3. Should have an x. Oh, this should not have it. Yeah, that's all right. That's it. This should have a square on it. That's what I was missing. Okay. So I'm going to have a times of 2, x plus dot 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 plus. Uh, over here, I'm going to have n, and bring down the n minus 1, x to the n minus 2, and then that series continues. So what does that look like for our nth term? Well, it's going to be the sum of, this is going to equal, that should be plus, equals n minus 1, x to the n minus 2. And now our series goes from 2, because we've counted off 2 terms, x to the infinity. Okay, So notice here then that our derivative of 2 over, our second derivative of 2 over 1 minus x, the quantity to the third power, is equal to this sum equivalent over here, okay? Which is true for whenever x is between, all of these series are valid representations for whenever x is less than or equal to, or sorry, just strictly less than -1 to 1. So whenever x is in that interval, these series are valid. Okay, all right, I hope that was helpful. I'll see you in the next video.